Dummy variables in regression. As you might know, in multiple regression, the dependent variable and independent variables must be continuous variables. In other words, the variables that are measured on at least interval or ratio scale. Of course, we have some variables that are measured on a nominal or ordinal scales. How do we incorporate these variables into the regression equation? In particular, when we have a nominal variable like gender, like race, this type of variable should be dummy coded. In other words, we have to use a dummy variable to represent these type of variables. A dummy variable is a variable that has only two values, 0 or 1. If you look at the notes, in this case, you see you have x1 is a dummy variable because it has a value of 1 if the treatment A is used, 0 otherwise. Or x2 is 1 if the subject is male, 0 if the subject is female. There is another type of coding dummy variable, and one and negative 1. I'm going to talk about that later on in this type of dummy variable, but at this point, we concentrate on only coding dummy variable as 1 or 0. Back to our SPSS data set. In this SPSS data set, systolic blood pressures and age of the men and women are measured. So we view systolic blood pressure as a dependent variable, age as independent variable. And we have the gender, capital M stands for male and capital F for female. We're going to here run two regression equations, one for male and one for female. And in order to do that, I click on Analyze at the top, and regression, linear. I move the systolic blood pressure to the right as in a dependent variable box here. Age goes to independent variable. I highlight the gender and move it to that variable selection or selection variable. And as you see, you have equal and a question mark. We click on rule, and then come up with this value of these two categories we have. For the female, we use the capital F. So I use it exactly, should be capital. If it's lowercase, should be lowercase because this is a case sensitive situation. So here is capital F, so capital F appears here. I click continue and then click OK. And the output shows up here. I'm going to delete this part of the table right now. I don't need it. Only I'm going to concentrate on the coefficient table. In this regression, it's called unstandardized coefficient. We have the slope, which shows the change in systolic blood pressure for a 1 unit change in age. So in other words, as we get a year, or a female gets a year older, her systolic blood pressure goes up by 0.95, and that's known as a slope. And this one is an intercept, which is at age 0, you can say, at the starting, this is the systolic blood pressure. But of course, this doesn't make sense. The reason for that, because these are adults subjects, so we cannot really talk about the subject below 18 years old. But anyway, that's the line when the line intersects the y-axis, which is the systolic blood pressure, and that's 97 is a result. So again, as you see, we have gender equal female, and that's the equation. We can come up with the equation. It's called regression equation for female. I'm going to repeat that process and calculate or compute the regression equation for male. So I go to regression, linear, and this time only highlight that gender equal F and click on rule and change that F to capital M, and then continue and click OK, and then the new set of output will be the results. Again, I'm going to highlight each of these tables and then push delete. Only I come up with this coefficient. Again, this is a coefficient, our regression coefficient here. You see constant and age for male. All right. So you can plot that, and I've done that in the notes. If you go back a few pages down, and you see there are two lines for the male and female. So that's a line. As you see, this is a systolic blood pressure in a y-axis,